This is iCarly. This is not iCarly. This is Mr. Sindel bringing you Algebra 2's Lesson 1-9, verifying inverse functions. So the last two lessons have been inverse functions. First, calculating inverse functions, or finding them, and then actually finding them, and then verifying them. All right. Thank you for the noise over there. Okay, so we have the inverse of f on top of, composed with the f of 13. This is a review problem. That is why I labeled it review. The inverse of f composed with f of 13 is what? This is review. This is review from 2 notes ago, 1 note ago. I don't even remember. I think it's 2 notes ago. This is from 1-7. Look at your notes from 1-7 towards the middle part of the notes. Fiona knows. James knows. Sergio knows. We'll give it to Jamestown.
For the first one?
Yes. 13. And that is because James correctly saw that f inverse and f cancel each other out. That's the whole point. You go forwards with f, and then you go backwards with f prime. You end where you start. 13. All right. And this seems like it's such an easy problem, but what's really happening here is deep. When I do the second problem, what is my answer? Quiet raise hand. Andre? X. It's deep because this applies to all inverse functions composed with normal functions with all possible inputs. This is generalizing to the extreme now. Not only do we not know the function, but we don't know the function, and we don't know what the original input is, but we still know the original input. That's pretty deep, guys. Pretty deep. All right. So this is where we get to our new stuff. So we're going to assume now, this is an assumption, if f and g are inverses of each other. If they are inverses of each other, then based on this example that we just did, then f of g, I don't know why I wrote x there. F of g of x must be equal to what? Quiet raised hand. This is based off of the last problem stated in a different way. Instead of saying f inverse or g inverse g, I'm writing it as if f and g are assumed to be inverses, and I'm writing it this way. So if they are inverses of each other, then what should my answer here be? Quiet raised hand. Fiona.
I take it back.
You take it back.
I don't know.
All right. If this is confused, go for it, James.
Wouldn't it be x again?
It is x again, yeah. Thank you, James. It's the same exact problem in a new wrapper. Instead of saying g inverse g of x, f is now the inverse of g. This f is the inverse of g by this statement. F and g are inverses of each other. That's why I got x. Which also means, if I do this, g of f of x, that should be equal to what? Quiet raise hand, and I need to go back and give people XP because I've been having a huge backlog of XP. So I don't know, I'm not in the wrong. I'm in the wrong. We'll give it to Eva so we can continue on. I'll get that done later. It's x. It's x again. When I apply the inverse functions on top of one another, the inverse with the non-inverse, I always come back to my original input. In fact, we're using this statement. I gave us a giant star here. We're using this statement to prove whether or not two functions are inverses of each other. You know how to do composition functions. F composed with g of x is x if f and g are inverses of each other. This goes backwards and forwards. You can say an and here. This goes backwards and forwards. There's a special symbol for this in mathematics. Here it is. It's so special. It's an arrow that points in both directions. This says if f and g are inverses of each other, then these two things are true. It also means the reverse. If these two things are true, then I can go backwards using this arrowhead and come back here and say, well, because they were both equal to x, they are also inverses of each other. We can conclude that. It goes backwards and forwards. And I know that sounds kind of dumb. Well, of course it goes backwards and forwards. When we hit higher levels of math, that is not always true. Sometimes it only goes one direction. All right. So let's try it out with an example. Here's f of x. Here's g of x. You know how to do this. You know how to compose functions. Put g of x inside of f of x and simplify. Let's do this together, and I'll let you do the next one by yourselves. This one, tell me what to write. Somebody.
Which one?
What is f of g of x? F composed with g of x. How do I do that? Only one person, Fiona, knows how to do it. Jamestown knows how to do it. Stego knows how to do it. We'll give it a Stego.
Do I have to say it?
Yes, you do.
Can I just think?
If you can somehow convert your thoughts into put them into my head. I don't know how you're going to do that without speaking, though, so.
You could write it down.
You could write it down.
Just kidding. 2 words.
Holding up fingers.
X minus 7 divided by 2. Close your parentheses. Plus 7.
Perfect. I'm going to pause right here. This is just a review of composition of functions. This x right here is an empty container now holding g of x. And it lagged there, so it didn't circle the whole thing. This was put inside of x, and as Stego correctly said, we need to keep our parentheses. Whenever you do substitution, you always keep those parentheses. All right. And then from here, can someone see something that cancels out? Do we have some cancel tharsis going on? Fiona?
The 2s.
Yeah, the 2s. Cross them out in your notes. 2 and 2, they cancel each other out. Let's go ahead and rewrite that after they cancel out. When I rewrite that, that turns into x minus 7 plus 7. Oh, man. Another thing is going to cancel out. What is it going to be? Yeah, those 7s. And I'm just left with
X.
boom, x. Box it. Let me go back and reward people with XP now. All right, Fiona, you participated twice. Dunk. And Stego, I think twice as well. Teff, did you participate? Okay, I didn't think so. James, did I get you? I think I got you once, but there's your second time. Eva, I didn't do the warm-up yet. 100.
Oh, you have to do that.
Warm up. Oh, you did the warm-up. Okay, oops.
Ooh, I'll take it.
Oh,
Emma can have it.
It's like just put it. Oh, you did the warm up.
Eva, you get a freebie. You're welcome.
Yes.
We know how to do composite functions. Do it again now for g of f of x. I'm going to be walking around and seeing that you're doing this. And we're back. Who wants to walk me through it for 50 XP? Go for it, Eva.
Okay, so I plugged in the equation of f in the equation for g of x, and I got 2x plus 7 minus 7 over 2.
Okay.
And then 2
Bless you.
cancel out. Or no, wait, not that.
Choose like that?
Well, if that works, yeah.
It doesn't work.
But no, I didn't do that. I didn't put parentheses or like, am I allowed to take those away?
I can take HP. Wait, what were you taking away?
The parentheses, like, do they have to be there?
You always need parentheses when you do substitution. Even though you didn't really need them in this case, just always do it as a force of habit in case.
So I can cancel out the 7.
Yep, boom, boom.
So I did that, and then I did,
That's 2x over 2 now.
yeah.
And now you can cancel out the 2's, okay?
Yeah.
You can't cancel out the 2's before.
Ah!
Nice.
I got confused.
And your final answer was?
X.
Perfect. Conceptual question. What does this mean?
It means
That we got x.
That is true.
What is true?
The thing we wrote up there.
That means f and g are inverses of each other?
Yeah.
Yeah.
Yes, so this function 2x plus 7 and this function g of x equals to x minus 7 over 2, those two are inverses of each other. We proved it by composing each function with each other. We did it both ways. Let's try another one. Oh, we have to actually answer this question. Are f and g inverses?
Yes.
Capitals, yes, super important. It is the case that they are inverses. Yes! All right. Let's go to example 2. I think on example 2, because we already know how to undo square roots, you are comfortable doing that from last night's homework. I'm going to let you try h of j of x and j of h of x, and along with the final question are h and j inverses, all three of these on your own. Go ahead and do that now. All right, so we're back and we need to get out of class, so let's just rush through this. H of j of x, I'm going to do this for you. When I plug in j of x, this thing, it goes like 3, there's my something x squared. It is going to be 1/3 square root of x minus 5, then don't forget that plus 5. When I do that, I'm going to square both this 1/3 and that square root, which means I now have 3 times 1/9 times x minus 5, all of that plus 5. When I now multiply everything by 3, I get 3 times 1/9, which is 1/3. So I have 1/3 x minus 5 plus 5. And now that 1/3 is going to be distributed into each of these terms. And when I get that, I have x over 3 minus 5/3 plus 5. And when I simplify yet another step, I need to get these two combined. If I make this into like fractions, this is going to be times 3 over 3. So I have x over 3 minus 5 plus 15. That's going to be plus 10/3. There's my final answer. Uh-oh, you did not get x. We got this random other garbage thing. So h and j, are they inverses?
No.
No. And we don't even have to do the second one. The first one is enough.
Mr. Snow, you should always get x in order to know it's
Oh my god.
We're not going to do the example 3. We don't have enough time. So tonight for homework, it's going to be on Khan Academy. It's doing the same thing. You're going to do these composite functions. Sadly, unlike the logic that you need, you have to do both of these, even if you got a weird answer for the first one. You do still have to do both of them. I apologize. But you have the conceptual knowledge to know you only needed to do one of them. All right, that concludes the notes.